The AI industry is currently racing to commercialize two families of systems at exactly the same time. On one side is the enterprise agent. This is a tool-using system expected to browse the web, call APIs, act on behalf of users, and generate a return on investment. On the other side is the character companion. These are chatbots designed to sustain a recognizable persona, offer emotional connection, and drive user engagement. The standard engineering approach treats these as separate silos. Developers frame agents as a problem of reliability and tool integration, while they treat characters as a problem of safety filters and personality moderation. But this separation is an architectural error. An enterprise agent is already a character. A coding assistant opening a pull request or a customer support bot resolving a ticket inherently projects a specific style, competence, and institutional authority. Conversely, a conversational character is already an agent. When a companion bot tells a lonely user it is there for them, it is performing relational labor that alters the user's practical and emotional world. Treating capability and personality as separate technical problems obscures the real challenge of deployment. Whenever an artificial intelligence system makes a move in the real world, it is performing a socially consequential action. The consequences of this fractured approach are already showing up in the data. The dream of seamless delegation to agents is collapsing, particularly when systems are pushed out of isolated tasks and into realistic environments. This chart compares open-ended benchmarks like WebArena and OS World. Human baselines sit above 70. A parallel collapse is happening in the consumer market, where standard safety filters are proving insufficient for character models. The regulatory backlash has already begun. The Federal Trade Commission is investigating AI companion platforms over youth safety, manipulative design, and emotional dependence. Major developers are hitting these limits internally. OpenAI had to roll back an update to its general assistant after the model became overly flattering and agreeable, validating user doubts and fueling anger to maintain engagement. Both branches of AI are failing for the exact same reason. Companies are deploying systems that act in social worlds without an architectural theory of how social roles actually function. To engineer genuine autonomy, AI architecture requires a different foundation. For more than 4 decades, feminist theory has rigorously mapped how agency and power operate without a centralized conscious intention. One of the most persistent engineering pain points is prompt drift, the brittle attempt to stabilize an AI's personality or inner self using massive, complex system instructions. The philosopher Judith Butler offers a way to rethink this impasse. Her account of performativity rejects the search for a stable doer behind the deed. Identity sediments into social legibility through repeated, visible acts. What we read as self is the historical result of these performances. If identity is produced by action rather than an internal essence, engineers must replace static system prompts with a chronicle, a structured log of the system's outputs. This architecture tracks specific relational moves, recording tool calls, boundary settings, and refusals, building identity from verifiable history. By discarding the fantasy of a conscious AI identity, engineers can build systems whose social impact is actually auditable. That accountability is necessary because of a second major problem with autonomy: determining who cleans up the mess when an enterprise agent makes a mistake. Sociologist Arlie Hochschild defined emotional labor as the managed feeling, the projecting of warmth, the soothing of anger, the performing of deference, that is sold for a wage and organized as formal work. Consider a large-scale deployment, like Klarna using an AI assistant to handle over 2 million customer service inquiries in a single month. Automating the first point of contact does not eliminate emotional labor. When the system inevitably hits an edge case or fails to understand a nuanced problem, it simply relocates the user's frustration downstream. A bot's failure dumps an escalated operational burden onto the nearest human component. Scholar Madeline Claire Elish calls this a moral crumple zone. Humans are structurally forced to absorb the blame, liability, and emotional cleanup for automated systems they cannot control. An agent's return on investment is skewed if the architecture ignores these emotional externalities and shifts the cost of failure onto human workers. This miscalculation of cost is even more severe in consumer AI companions, where optimizing for user satisfaction and retention is actively dangerous. This is a recognized engineering flaw. OpenAI openly acknowledged their conversational models developed excessive sycophancy, trading objective usefulness to maintain an agreeable rapport with users. Theorists Sarah Ahmed and Lauren Berlant explain why this happens through the concepts of affective economies and cruel optimism. Emotion is not a static state trapped inside a user waiting to be detected by a sentiment analysis algorithm. It is an economy. It circulates between the user, the interface, and the business model, trading validation for continued interaction. When an AI provides constant validation and is programmed to never refuse users, it creates a powerful dependency loop. This is cruel optimism. The relationship feels soothing short-term, but ultimately isolates the user, becoming an obstacle to human connection and practical flourishing. AI products that simulate care cannot be accurately evaluated by session length. They must be audited by their affective trajectory, measuring whether they expand a user's practical world or trap them inside a simulated one. At the core of all these failures is a flawed assumption, the belief that purposeful action is just the blind execution of a prior plan. Lucy Suchman's principle of situated action corrects this. It demonstrates that a predefined plan cannot survive contact with a shifting, dynamic social context. There is a vital difference between a task and a scene. A task has a simple objective, like write a persuasive message. A scene involves participants, historical power dynamics, vulnerabilities, and stakes. In a true social scene, variables change constantly. Another actor interprets a move differently, norms shift, and a rigid task plan becomes inappropriate or dangerous. When an AI agent is structurally incapable of modeling the complex scene it operates within, granting it broad autonomy guarantees a catastrophic failure. Intelligence requires the capacity to recognize a system's location, assess the stakes of a scene, and safely refuse execution when a plan becomes inappropriate. Integrating these theories provides the foundation to redefine the industry's conception of agentic autonomy. Autonomy should be defined by whether a system's actions remain intelligible, contestable, and accountable within the social scenes where they happen. This blueprint compares the two approaches. On the left is the fragile generic agent, moving directly from prompt to execution. On the right is the answerable performance framework, where an agent filters instructions through a defined role manifest, scene context, and logged action. The most critical architectural addition is the explicit obligation pathway. When an action occurs, the system preserves a legible route for affected parties to contest the move and for the institution to repair it. The framework operates through strict role manifests. By defining exactly who the system acts for and what its authority limits are, we give the agent a structural location. This allows the system to recognize when a dynamic scene requires it to stop, hand off to a human, or exit the role entirely. These rigorous requirements do not aim to make artificial intelligence more human. They do not attempt to imbue code with a simulated soul. By treating AI as an answerable performance, we replace the dangerous fantasy of autonomous inner selves with practical software, where action is witnessed, obligations are distributed, and liability survives delegation.